Sheela, Nistala. I've been an engineer with Reliant for a couple of years now, working as an administrator. To give you a little bit of a background about Reliant, we are a company that sells an appliance that's a converged infrastructure solution. We mostly cater to retail and restaurant chains. What that essentially means is that we aggregate all the functionality served by different systems in the store in one box, and the box looks like that. Functionality like networking, VPN, in-store music, in-store Wi-Fi, firewall rules, and much more. Some of our customers are retailers like Hudson News, Party City, Walmart, Barnes & Noble College, Gucci, Chanel, and restaurant chains like Arby's, Smoky Bones Bar and Grill. We manage over 5,000 physical nodes and over 15,000 virtual nodes, all running Debian, completely managed via Puppet. So how we do this is we write a custom module every time a request for functionality comes in. We have over 130 modules in our repository, each from generic SSHD, Nginx, Nagios, to more store-specific functionality like OpenVPN, Squid, Reliance custom music player in store, and some GVR solutions, payment applications, file integrity monitoring, and all that. So the result of this is that we have cleaner manifests, and we know exactly what's running on every node, and we spend more time on development rather than repeating ourselves over and over again. Just a quick question though, how many of you are familiar with writing custom modules? And okay, so not all of you are going to fall asleep in the talk. So modules, what are they? They're essentially self-contained blocks of code and or data. They're just a collection of classes that serve a certain specific functionality. They are easily deployable. Meaning that someone that wants to use a module or install a module should not have to go through the code to figure out what the module does. And to that end, the documentation of the module should be good, and they should be able to interface with other components easily, and they should be reusable, of course. And speaking of reusability, there are some great modules in the Puppet Forge that everybody should use and install, but this talk is more focused on developing custom modules in case something that you want is not available in the Forge or you want to contribute to the Forge. So this is what a typical module's layout is like. In the Puppet Master's module path, there's a directory whose name matches the name of the module that you want to create. So in this case, there's a module called My Module, and the directory name should obviously be the same. Under that, there's a manifest directory, which contains your classes, parameterized classes, defined types, all of that stuff. And the files directory contains static files. These can be your service start scripts, stop scripts, whose content doesn't change. Templates directory contains dynamic configuration files. Basically, the variables that you take from the user configures these templates. The lib directory contains plugins, which are your functions, custom packs, providers, things of that sort. And the spec directory contains unit tests. Before we go into the development of the module, I want to make a quick note about Geppetto, which is an IDE for developing and validating your Puppet manifest. It's great because to get started with module development, you can get started with Geppetto. It's going to create a custom module for you. You can download a module from Forge and edit it. So when you choose, when you want to create a custom module, it's going to create the files and directories for you from scratch, and all you need to do is just open the file and start writing code. It provides syntax highlighting and many more great features. So it's often best practice to name your class to match the file name. So take for example the SSH module here. In your manifest directory, you have a file called package.db. So your class name should obviously be SSH package. So it's easy for someone reading your module to figure out where a particular class exists. So before we start developing the module, there are a couple of questions we ask ourselves. What are we trying to do here? Are we trying to extend a module that already exists, or are we creating a module from scratch? And oftentimes solution where all you need to do is just extend a module that you already have. Second, we need to identify what files, what resources we're trying to manage in the module. What files, what services, what users, what exactly you're trying to manage. This is oftentimes an iterative process. You don't always end up in the right state right away. You start off with managing a package, and then you go improving that module, start injecting dependencies in your module. So this is a time-consuming process. Next, if you're accepting parameters from a user, you need to choose between using a parameterized class or a defined type. How do you choose between both of these? A parameterized class, as classes in Puppet are singleton, you can only have one instance of them on your, one declaration of them in your node definition. The syntax is just the same for both, essentially. We have, this is a good example of when you use a parameterized type as opposed to a defined type. So you have a class MOTD that just takes a variable message and sets the content of etcmotd to that variable. So in this class, you're just essentially setting the content of a file. So this would be a good use for parameterized class. You have, if you want to override content, you can just declare it like that, but you cannot do that more than once. Obviously, you don't need to manage the same file a couple of times, and you can't. Defined types, you can obviously have multiple instances of that. So for example, here in the account defined type, all we're doing is just creating a directory called home title and a user. So in the first case, account foo, it's going to create a user called foo and a directory called home foo and sets the home directory of that user. Obviously, we want the capability of having multiple accounts on your machines. This is where you'd use a defined type. So identifying this is kind of important before you start writing your classes. So we'll go ahead and create a first module, which is a simple module that manages OpenSSH server. All it does is install a package, manage a service, and manage an sshd config file. There's a Puppet phase called Puppet module that you can use to generate the basic directory structure and the basic files. So all you need to do is Puppet module generate, and you need to specify a username hyphen module name, and it's going to create the directory structure for you just like that. So this is what our main class will look like. The init.pp file should contain the class name, which is the same as your module name. So in this case, our module name is sshd. So the init.pp contains the class sshd. Just a simple package resource called OpenSSH server that we're installing. Ensure that it's installed. A service called SSH that's running, and a simple config file. And we add the config file to our files directory, as you can see from the source attribute of the file resource. So in our files directory, we have the sshd config, which has some basic configuration, permit root login, port number, login grace time. So on nodes that we want to deploy this to, deploy SSH to, all we need to do is just include sshd and life's good. We have SSH running, we're managing the service, we ensure that it's running, and we have a basic configuration file. Not so great, but we'll do for now. But there's a couple of things that are wrong with this module. What about a different operating system? What if the name of the service is sshd? What if the package name is different? There's no way that this module is portable. It's going to run on a specific operating system. And the config files are static. Config file is static. So it will only run the configuration values that you've specified in that static file. So it's going to run only on port 22 with login grace time on port 20 or whatever that was. Now if a new node needs to be introduced in your environment, running say Red Hat, and it needs to run SSH on port 2222, what do you do now? This is where I'd like to introduce something called patterns. Every module that you'll see on Forge or otherwise, you'll see that they follow certain patterns. One of these patterns is called the params pattern. This is where you have a class called the params.pp, and you add all your variabilized data from your manifest to the params.pp class. So here we just initialize a variable called package to OpenSSH server, and this, depending on the operating system of your node, The value of the variable service is either SSH or SSHD in case of Red Hat. So we'll refactor the init.db a little bit. We include SSHD params class here, and instead of having a static string called OpenSSH server ensure installed, we'll take the variable from the params class and we'll ensure that it's installed. The same thing goes for service. You can do the same thing for the file resource too. But the problem still exists that we are still sourcing the sshd config file from a static file. So let's refactor the class some more, and we convert the class to a parameterized class. So we accept certain parameters called port, permit root login, yes or no, login for raise timeout, and other things. And we set same defaults for these. So in case the user wants to use the module as is, he doesn't have to configure the module every time he wants to use it. So we set same defaults. For example, port number should always be 22, and permit root login should be no. The user should be able to override these variables if he wants to. And then we change the source attribute of the file resource to content. So now it picks up the content from a dynamic template directory. And in the templates directory, we have an sshd underscore config. It's an ERB file which picks up the parameters from our class and or whatever the values the user provides. So on nodes that we want to, we don't care which port it runs on or other values, we just use a node 2, we just include sshd. And on a different node which needs to run SSH on a different port, we use the same syntax to specify the port number of the parameter. We spoke about the params pattern. There's another commonly used pattern in modules which is called the package config service pattern, where you split your main class into 3 separate classes, one handling the package, one handling the resource and the service, and the other handling the file. And then you have one main class that binds them all together, that serves as an entry point to your module. And this is where you inject dependencies, and you can do, you use something called an anchor pattern. That's something like this. So what this is essentially saying is, first install the package, then create the config file, and then create the service resource. And every time the config file changes, the service resource is refreshed. So you have all these dependencies injected in a very simple format like this, if you use the package config service pattern. This is very commonly seen in most modules also. I mentioned about using same defaults for class parameters. But there are some situations where you'd rather not have defaults. See for example, this one. There's a module called my module that does something very sensitive on your machine. And you're setting defaults here, admin user and admin password. Now, when you run this on your machine, it's going to install the whole module and it's going to work just fine. But you'll still have insecure credentials on your machine. It's going to be running with admin. Rather than that, don't provide any defaults at all for your module. And when Puppet run fails with that error, it says must pass admin user to the class, you know that, okay, so I need to set the parameters myself. So that way you're at least not silently failing. You'd rather, silently passing the installation. You'd rather fail than provide insecure defaults. There's another thing that's wrong with the params pattern, which is, I think, will soon be obsolete. All the logic of assigning variable names is being put in the params.pp class. So you have case statements, and depending on your operating system, you have multiple variables assigned in multiple places. And every module that you create, you have to have a params.pp file. And all this logic must be repeated in every single module that you write. Sure enough, we've separated all the data and we've put it in a separate params class. But technically, it does still reside in the module itself, and in turn, it resides in your repository. So to truly separate data from code, we use Hira. Hira is a hierarchical data lookup tool. It supports various backends like YAML, JSON, Postgres, Redis, and others. Now you can either refactor your params.tp or you can call hira directly from your classes. We use the hira function to do this. So what you're saying in that hira function is look up the value of the variable ssh_package or ssh_service. Now if that variable is not found, we use the first syntax to fall back to a default if nothing exists. So now hira is going to take care of the lookup the variable for you. The module author doesn't have to worry about accounting for different operating systems or different distros and things like that. So in your hira.yaml file, you specify the hierarchy. So in this case, we'll look up operating system specific variables first, and if that's not found, it's going to fall back to common. And let's just use a simple YAML backend for now. And in your etc puppet hira data directory, you have 3 files, which is your debian.yaml, redhat.yaml, and common.yaml. And this is where you can specify what those variable names should be. As you can see, this is pretty common syntax. And now if a new operating system comes up with a different package name and a different service name, the module's author doesn't have to worry about changing the whole module and all that kind of stuff. All you need to do is just create a new YAML file for your new OS, assign the values of the variables, and you're good to go. Puppet 3.x and higher even supports automatic parameter lookup like that. So that was our initial sshd class. All you can do is create your debian.yaml file, say, and you can use that syntax to assign values of variables directly. So in your node definition, all you have to specify is include sshd. And you still want to override that, just create, in hira, just create a YAML file and specify, override the values of those variables. So now we have a great module up and running, and we've separated data from code, built up all that kind of stuff. We need to test our modules. There are a variety of tests that you can perform on your modules, starting from checking for your coding styles, smoke testing, to more complex unit acceptance testing. Smoke testing is a preliminary test that you conduct on your modules to check if you broke something, does the module do what you expect it to? Does it work correctly? So in this case, we use the no-op flag puppet agent. The no-op doesn't change any resources, but will tell you exactly what's being changed where, without actually changing the resources. So here we made a typo. We specified ports instead of port, and it shows you clearly that there's an invalid parameter called ports, and so it's a line number. So running it in no-op will often tell you what exactly you're going to break, rather, when you deploy that module. Puppet lint is another cool tool, I guess. It's pretty easy to install. Just install the Puppet lint gem and run Puppet lint against a manifest. And as you can see, I have trailing white spaces everywhere in the manifest. And on line 19, for some reason, I've double quoted a string and I haven't enclosed it in parentheses. So the styles that have been defined in the Puppet Lab style guide will be verified by Puppet lint. RSpec Puppet, this is my favorite tool. It can be, as the name suggests, it can be used to write RSpec tests for your Puppet manifest. RSpec Puppet cannot be used to test the results of a manifest on your system. You don't know how a module is going to behave in a system using RSpec Puppet. Rather, it's used to test the behavior of the Puppet when a catalog is compiled. Does your catalog contain X, Y, and Z resources? Does it behave the expect? Does it create the catalog the way you expect it to? This is used for testing more complex modules. A simple module like the sshd one that we just wrote probably doesn't warrant RSpec test. Setup again is very simple. Just install the RSpec Puppet gem, cd to your module, and if you do an RSpec Puppet init, it's going to create the whole directory structure and all the files needed for RSpec Puppet to work. You can write tests for your classes, for your defines, for your functions, for your hosts, and you can check the catalog for all these resources. So let's test the behavior of let's test if the catalog contains whatever we have defined in our initial manifest init.pp. So we describe the sshd class here. We specify that the catalog should contain the class, the catalog for sshd should contain the class sshd params. It should contain the file sshd config with ensure present, and contain the package OpenSSH server with ensure installed, and it should contain that service with ensure running. You can even change resources here, like for example the file sshd_config. You can change, you can say something like it should contain that file with ensure present, with user so and so, with owner so and so, group so and so, things like that. So now we run the test against a module that we just run our spec and the spec name, and you can see here that the test will obviously fail because that test expected that the catalog would contain service SSH. If we go back to our SSH service resource at our params class, you see that the catalog will not contain service SSH because a Red Hat machine is going to contain the resource service sshd. So now we just add an extra line, the first line there. We specify that the catalog on which there's an operating system fact, and that fact is Debian. On those machines, this is what the catalog should look like. And we just refactor the test, and obviously that's going to pass. So some other cool tools that you can use for modules are Puppet Librarian. Puppet Librarian is to Puppet modules what Bundler is to Ruby gems. You can simply have a Puppet file where you can specify what modules you want to install and from where you want to install it and what version of the module you want to install. And you can use it in combination with R10K. R10K is used to manage dynamic environments. It can be used to deploy environments and modules. You can have certain environments running certain modules, and you can lock down module versions to those environments using Puppet Librarian. And for acceptance testing, you can use Beaker. Beaker can be used to provision your nodes, test your modules, revert back to the original state, and destroy your VMs and things like that. I think it supports Vagrant and VMware, if I'm not mistaken. So yeah, so that's now that you've finished testing your modules, of course, publish them to the Forge. It's pretty easy to publish to the Forge. Just upload a tar file of your module, and it should be good to go. So in summary, when you're using parameters, always validate your parameters. Don't set insecure defaults. You'd rather not set any defaults to your parameters. And follow patterns in your modules, and always write tests for your modules so it becomes easier for you later on. And that's about it. Thanks everyone for listening. If you have any questions. If you have any questions, you could either ping me on IRC or Sheela on Freenode, or
okay. Who's first? I know you've got questions. There we go.
Hi Sheila, thank you for your talk. I have a question about hierarchy. So what is the hierarchy of hierarchy, where you might have something defined where all of your East Coast data centers use EDT, but you want something in UTC. So is there a way in hierarchy to is there levels of data center first, and then host type, and then specific host layers, or is it all, can you only define something once for a specific thing?
No, you can specify as many hierarchies as possible. As we saw, we specified the operating system hierarchy, and we just fall back to a common one. But you can have 4 or 5 levels of hierarchy. I would suggest over 4 levels of hierarchy, but yes, you can have multiple levels of hierarchy. Thank you.
Another question? There we go.
Hi, well, new to Puppet, but are there any best practices on using continuous delivery Jenkins, for instance?
Sorry, should you repeat that?
Are there any best practices with using continuous integration tools like Jenkins with
Right. Yes, the most common one, of course, I've heard is Jenkins, but I guess I'm not a user of Jenkins, so I'm not qualified enough to make that statement. Probably somebody else could answer that question better.
Oh, Matthew, you gonna talk about that? Oh, Sam is? Yes. Sam's gonna talk about that. We're all really excited.
So there you go.
I shall have a question. The manifest that you showed earlier where you have the credential admin, and the way it could be configured, right? So you would have to enter, once you run Puppet apply, so you would manually have to enter the credential, right? So if you have, let's say, 1,000 machines, so you would have to do that once and it would get propagated to all the machines, is that correct?
Ideally, you'd use Hive or something like this, right? So if you have 1,000 machines, you obviously are not going to have 1,000 node definitions, right? You'd use Hive or something like this. So you'd have one file that contains your credentials or something like that, and use some kind of hierarchy to pick up your username and password from a file like that. I'm not sure if you heard of the roles and profiles pattern. Right, so you classify your roles, you classify your nodes based on, say, it's a web server, like you have 100 web servers. All those web servers should have X configuration. So that's where you create the roles and profiles pattern, and you assign your credentials like that. And of course, you use hierarchy combination with that, so you just have one or two files controlling your credentials. Thank you.
Back there, back around. Over my head. Sorry, this is. Thank you so much. Oh, I'm never gonna make it to you. Right at the center. Yes. Oh, there we go.
Hi, I have a question about for testing. I guess writing like RSpec testing.
Okay. Let's try to find.
Can you demonstrate how it does, or how frequently best practice it is to write testing, and how that will sort of, for writing custom modules, how that will save time, or does it save time, or how does that work?
Okay, so it saves, depending on how you define your time, because you can write RSpec tests and you can do test-driven development. Obviously, it's going to be way faster if you have an RSpec test running against your module and you write your manifest, right? So if you write that RSpec test first that we just saw, you know that these are the resources that are supposed to be there in your manifest. So developing your manifest becomes way faster, obviously. So that's how it can save time, and of course it can save you time in terms of if you're writing complex plugins like facts and custom plugins and custom providers. It becomes easy to test it. You can catch all errors early on in your development.
We have a question back here.
So how many number of servers did you have? You had quite a lot of servers from the
Oh, right. Yeah, we have like.
So, and then that means you have multiple data centers, certainly?
Actually, we don't have the concept of data centers. Each of those nodes that I'm talking about are distributed among our customers. So we have all our customers' networks, and under those networks we have all these red boxes running.
So the reason why I'm asking this is because now that you have so many number of servers, how is the performance on the Puppet master? So because the catalogs get applied by the master, right? So then you have like thousands of servers, and all of the agents who are actually looking for a catalog, what's the statistics on the performance?
Okay, so I think the maximum we have running against a Puppet server is probably 2,000 nodes. I think that's the maximum we have against one Puppet server. There's a great talk by Carla Souza from PuppetCon last year. You should probably listen to that talk to understand how we do this. We mostly use Hyra and a combination of a lot of things to ensure scalability in these sites.
And 2,000 servers you are able to handle efficiently?
2,000 nodes, yes.
Okay.
Yep.
Thanks.
Online as well. More questions? Over the front.
Two questions really. Like, first thing is like, there are a couple of modules that are there on the Puppet Forge. So when you're writing your own module, like, what's the best practice? If you wanted to use some module that is there on the Puppet Forge. And second question was like versioning. Like, if you have like the Puppet code done and then you're continuously like, updating it or adding new stuff in it, how do you like manage the versioning of it? Like, if you want to deploy the next version of it?
Right. Yeah, first answer to your first question is, of course, if the module is available on the Forge, please use it, install it. There's no need to reinvent the wheel over and over again. Right? Second, there is a versioning pattern that Puppet Lab suggests. You can use that, and of course, versioning works for Puppet modules just like any other code. If there's a major change, it would make a major version increase, and if there's a small change, you keep updating your modules as you go. I'd suggest looking at docs.puppetlabs.com for versioning of your Puppet modules. That has probably more detail than I can give you right now.
For the first question, like, suppose you have to use like two or three modules from Puppet Forge into your own module. Is that possible to do that?
Yes, of course. All you need to do is just import X module, Y module. Yeah, of course, you can use 2 or 3 modules in the same.
If you have to run this as CIS compliance or PCI, some things, can you use RSpec or something else, or are there other modules available to check against, like, is your Puppet configuration matching the certain compliance policy?
You cannot use RSpec for something like that. But most PCI auditors will accept Puppet. I think Lindsay spoke about that most auditors will accept a Puppet manifest as to show. If you want to show your auditor that this is what my system configuration looks like, you can show them the Puppet manifest, and that's considered acceptable. But otherwise, you'll have to manually take care of things like that. I think there are some modules on the Forge also that apply to PCI standards and stuff like that. You can either use them, but there's no way to test if you're compliant with certain requirements using RSpec.
Is this presentation going to be available online?
Yeah.
Thank you.
So, about a week after the camp, if you go to puppetlabs.com, go to the Puppet Camp page. Technically, I think it's puppetlabs.com/community/puppet-camp, but you can just Google for it. It's pretty easy to find. You can go under past camps, and this camp will have all the slides and the videos lined up there for anyone. Any other questions? Very good. Excellent. Well, thank you so much.
Thanks, everyone.